Wow, this has to be the saddest video intro you've ever seen at a virtual conference. A bot creates a pull request, which is then rejected after waiting for days or even weeks. Sure, some would say it's just a bot. It doesn't have any feelings, don't make such a drama out of it. But let me make one thing clear. The drama here is not that a single bot's feelings are hurt. The drama is that bots are systemically disadvantaged when creating pull requests. Longer processing times, lower acceptance rates, and we are talking about bots that developers consider useful and that are expected to have a positive effect.
Show me a single study that proves that such a bias exists in the interaction with bot pull requests.
I'm glad you are asking, because that's exactly what we did in our study. We compared the project maintainer's interaction with manually created pull requests to the interaction with automatically created pull requests. Kind of human versus bot, who do we accept more, is there a difference at all? Before I go into the details of our study, let me tell you the story that motivated this work. In 2019, a team of researchers conducted a study with a student development team. A new team member was introduced. It was a bot that automatically improved the code quality by creating pull requests. The students worked with the bot for around 40 days, and at first, everything seemed to go as expected. The team members found the bot great and useful. They were all like, yeah, we don't want to miss it in future projects. It helps us to do extremely valuable work that the other team members don't have time for. At the same time, the researchers noticed that only very few team members felt responsible for the bot. You might ask, why? It was mainly because the bot did not have the ability to push the other team members to review its pull requests, something the human team members often did to find a reviewer for their own changes. As a result, the full potential of the bot was not exploited, and fewer code smells were removed from the code than would have been possible without much additional effort. The end. Now, since this was a case study, we could not be sure if the finding was solely indicative of a problem with this student team and with this particular bot, or if there was a systemic issue where bots are disadvantaged in a project by their limited abilities. And maybe also by a potential lack of social pressure to engage with the contributing bot. Most would probably agree that making a human contributor wait feels different than ignoring a bot. For these reasons, we aim to complement the findings from the qualitative study that I just described with a quantitative investigation. Our research question was, how does maintainer interaction with pull requests differ between manually and automatically created pull requests? To answer this question, we conducted a GitHub mining study. And the whole process can be broken down into 4 steps. We start by defining criteria according to which the interaction should be compared. Then we find a dataset that contains many pull requests from real-world open source projects. In this dataset, we now have to identify all the bots, and then we can compare the pull requests of the bots with those of humans based on the previously defined criteria. Sounds simple, right? The comparison criteria were selected based on the assumption that pull requests by bots would be accepted less frequently and processed more slowly. Therefore, we considered the following 4 proxy variables for maintainer interaction in terms of acceptance and interaction effort with a pull request: acceptance rates, time until first human interaction, time until merged by human, and number of comments by humans. We use GitHub Torrent as data source and limited the dataset to entries from January 2019 to June 2020. That's 1.5 years of data and corresponds to more than 20 million unique pull requests. Bots were detected using a combination of several methods. Mainly, bots can be identified by their name, activity, or account status on GitHub. One then combines automatic detection with manual inspection, and existing datasets of known bots from other studies finally help to further enhance the list. So at this point, we had a large dataset in which we identified the pull requests that came from bots. Now it's getting exciting. Let's have a look at the data. Our dataset consisted of more than 20 million pull requests. The interesting bit is that around 1.8 million human user accounts are responsible for about 2/3 of these pull requests, while less than 5,000 bots created the remaining 1/3 of pull requests. Further, we see that pull requests from bots are smaller. Bots add an average of 673 lines and delete 343 lines, while humans add an average of 4,280 lines and delete around 1,800. Here you see the top 12 bot accounts by number of pull requests. A large part of all pull requests deals with the update of dependencies, and this should definitely be kept in mind when looking at the results in the following. For the human contributions with which we compare the pull requests, the variety of content is of course much greater. Humans not only update dependencies and fix a bug, but also sometimes add a new feature. So far so good. These numbers show that already today a huge amount of pull requests come from bots, although there are way less bot accounts than human contributors. To answer our research question, we now have to check if there are any differences in the maintainer's interaction with these two categories of pull requests. As I said, this is a quantitative study, so what follows are some plain numbers for the moment, and afterwards we will discuss what they might imply. First, pull requests from humans were merged in 72% of the time, while pull requests from bots were merged in 37% of cases. These numbers are regardless of whether human or bot merged the pull request. The average time it takes humans to merge a pull request by another human is only 14 minutes, but it takes a human more than 10 hours on average to merge a bot pull request. Interestingly, looking at how long it takes for bots to merge pull requests, it is the other way around. Bots merge the pull requests of other bots after only 12 seconds, while human pull requests got merged after an average of 5.4 hours. Next, we looked at the interaction via comments, and we only looked at comments by human users. 23% of pull requests by humans receive comments by other humans, while other 2.2% of bot pull requests receive any comments by humans. The absolute number of comments that pull requests receive is relatively low for both types of authors, so there is a significant difference here as well, but not a substantially one in terms of effect size. Human pull requests receive an average of 2.52 comments, and bot pull requests receive 0.06 comments on average. Finally, one last comparison criteria was the average time until first interaction. We defined it as the time it takes a human to respond to the pull request for the first time, either in the form of a comment or by accepting or rejecting it. And here again we see a significant difference. It takes an average of 30 minutes from pull request creation to the first interaction with a human pull request, whereas it takes 12.3 hours for a human to respond to a bot pull request. An interesting observation was that the maximum time it took a human to comment on a bot pull request, excluding outliers, was 12.5 days. The maximum time for a human pull request to receive a comment was about 9 times smaller, at about 1.5 days. Whew, so many numbers. Let's summarize what's going on. Bots have a significant share in the amount of GitHub pull requests. Unfortunately, only a third of all bot pull requests are accepted, and these take longer to process than human pull requests. Whether it takes an average of 14 minutes or 10 hours to accept a pull request might not be decisive in most cases. But combined with the observation that bots contribute much less complex changes and should therefore be much quicker to review, and furthermore that over 60% of all bot pull requests end up not being merged at all, we see potential for change in the numbers. If bots make important contributions, they should receive as much attention as other contributors. Whether this means that developers have to change their behavior in dealing with bots, or bots need to be designed differently, remains a question that the bot community can explore. How exactly bots have to change to be more effective is something that we as a community still have to find out. But there's one thing we can already conclude. If, for example, someone does an evaluation study and benchmarks a bot against the interaction with pull requests from humans, keep in mind that an excellent bot might already be one that is accepted just as well as an average human contributor. There seems to be some bias in the interaction with bot pull requests, and we need to find out why this is the case. Only in this way we can design bots to support developers more effectively in software engineering in the future. I really hope that you enjoyed this short video. If you did, check out my YouTube channel /science. It's about software engineering research, and it doesn't matter if you're a scientist or a software engineer. I try to explain the science behind software engineering there in a way that is enjoyable for everybody and so that everybody can learn something. Thanks for your support, and if you have any questions, of course, feel free to ask them.